Introduction. A sprinkler system is a fire extinguishing system, other than a water mist system, that utilizes water as the extinguishing agent. Whether a building shall be provided with sprinkler protection or not is generally set forth in the NYC Building Code. Inspection, testing, servicing and other maintenance of sprinkler systems must be personally supervised and be performed in accordance with NFPA, National Fire Protection Association, No. 25 2011 edition. All multiple dwellings, factories, office buildings, warehouses, stores and offices, theaters and music halls, hospitals and asylums, and all public schools and other public buildings, churches and other places where large numbers of persons are congregated for purposes of worship, instruction, amusement, and all piers, bulkheads, wharves, pier sheds, bulkhead sheds or other waterfront structures shall provide such fire hose, fire extinguishers, buckets, axes, fire hooks, fire doors and other means of preventing and extinguishing fires as the Commissioner may direct. Required fire protection systems shall be extended or altered as necessary to maintain and continued protection whenever the building or structure is altered. Systems not complying with this section shall be considered to be impaired. It shall be unlawful to install or maintain any fire protection system or device that has the physical appearance of fire protection equipment but that does not perform a fire protection function where it may be confused with actual fire protection equipment. An example would be a CCTV camera that is installed inside a shell that resembles a sprinkler head, as seen in the image on the right. Sprinkler and/or standpipe system maintenance and inspections. Automatic and non-automatic sprinkler systems shall be inspected, tested and maintained as required by NFPA No. 25 2011 edition by a competent person holding AS-12 certificate of fitness and employed or contracted by the owner, to see that all parts of the system are in good working order, and that the fire department connections, if any, are ready for immediate use by the fire department. A detailed record shall be kept on the premises or other approved location, for a minimum of 3 years for examination by any representative of the fire department. A supply of at least 6 extra sprinkler heads shall be kept available on the premises, to replace promptly any fused or damaged sprinklers. Any head which has opened or has been damaged shall be replaced immediately with sprinkler head of similar characteristics such as operating temperature, orifice size, deflector orientation and thermal sensitivity. At least once every 5 years, the fire department connection or connections for a sprinkler system shall be subjected to a hydrostatic pressure test to demonstrate its suitability for fire department use. The test shall be arranged to be conducted by a master fire suppression piping contractor in the presence of a fire department representative. The contractor shall be hired by the owner or the owner's representative. There shall be 1 or more employees or individuals contracted by the owner with a certificate of fitness to inspect the sprinkler system following the standard of the NFPA 25 of 2011. Responsibility of the building owner. It shall be the owner's responsibility to maintain the sprinkler system and to determine the individual qualifications and competencies of the COF holder that performs the functions related to inspection, testing and maintenance of such system. Impairment coordinator. The building owner shall assign an impairment coordinator to comply with the requirements of study material. The impairment coordinator shall take the actions when a standpipe system, sprinkler system or fire alarm system is out of service. The impairment coordinator shall maintain records of all system inspections, tests, servicing and other items of maintenance shall be kept on the premises or other approved location for a minimum of 3 years and made available for inspection by any member of the FDNY. In absence of a specific designee, the building owner shall be considered the impairment coordinator. Out-of-service systems, POS. Planned removal from service, when the system, or a portion of the sprinkler system, is placed out of service for a scheduled inspection, testing, regular maintenance, minor repairs, or for construction affecting not more than 1 floor, the certificate of fitness holder and the impairment coordinator shall be made aware of and authorize the placing of the system out of service. Unplanned out-of-service condition, a serious defect in the sprinkler system including, but not limited to, an empty tank, a break or major leak in the system's water piping, inoperative or shut water supply valves, defective fire department connections, construction-related shutdowns affecting more than one floor, or complete or partial shutdowns of the sprinkler system, other than a shutdown for a planned removal from service. When a fire protection system is out of service, fire watch personnel must continuously patrol the area affected by the out-of-service fire protection system to which such person has been assigned, keeping constant watch for fires. Be provided with at least one approved means for notification of the fire department and emergency preparedness staff. Immediately report any fire to the fire department and notify emergency preparedness staff on premises. Be trained in the use of portable fire extinguisher. Be responsible for extinguishing fires limited in size and spread that can be readily extinguished. Maintain a record of such fire watch on the premises during the fire watch and for a minimum of 48 hours after the fire watch has concluded. Have no other duties. Fire department notifications for out-of-service conditions. Notification that a sprinkler system or fire alarm system, or any part thereof, is or will be out of service shall be made to the fire department under the following circumstances. 1. The sprinkler system or fire alarm system is or will be out of service on more than one floor of a building, or 2. The work or repairs cannot be completed, and the system restored to service, within 8 hours of the time the system was placed or went out of service, or 3. With respect to a fire alarm system, the work or repairs will require the fire alarm system to be out of service for more than 8 hours in any 24-hour period, or 4. One or more other fire protection systems in the area in which a fire protection system is out of service are or will also be out of service at the same time. The telephone numbers are as follows. Manhattan 212-570-4300. Bronx 718-430-0200. Brooklyn 718-965-8300. Queens 718-476-6200. Staten Island 718-494-4296. A. The initial fire department notification shall include the following. 1. A brief description and extent of the out-of-service condition and system it affects. 2. The area of the building affected, including the floors where fire protection system is out of service. 3. The type of occupancy. 4. The estimated time the system will be out of service. 5. The name and phone number of the person making the notification or the owner of the premises. 6. The building address. 7. Whether the fire protection system is out of service by reason of a planned removal from service, and if so, the reason for placing it out of service, or an unplanned out-of-service condition. 8. Whether or not the other fire protection systems are in good working order. B. When the certificate of fitness holder observes a minor defect or other condition not presenting a serious safety hazard, he or she shall report the defect or condition to the owner, and if the defect or condition is not corrected within 30 days it shall be deemed to be an impairment and reported in writing to the fire department, FC 901.7.5. Correspondence should be sent via email spkstp@fdny.nyc.gov or by certified documents to New York City Fire Department, Bureau of Fire Prevention, Fire Suppression Unit, 3rd floor, 9 Metro Tech Center, Brooklyn, New York, 11201. Identifying OOS systems using disks/tags. Systems that are out of service, both planned and unplanned, shall be immediately identified by placing a tag at each of the following locations: fire department connections, system control valves, fire command center or other clearly visible location in the lobby of the building, indicating which system or part thereof is out of service. Impairment coordinators/building owners shall ensure the placement of these tags by MFSPCs or MP, as restricted. In addition, for an unplanned out-of-service condition, a disc, white or blue, shall be placed at all affected fire department connections to inform responding fire department units of the out-of-service condition. The impairment coordinator/building owner shall ensure placement of these discs by MFSPCs, MPs, as restricted, or FDNY units. When the condition has been corrected, the discs shall be removed immediately. Tag requirement: a tag shall be used to indicate that a system, or portion, is out of service. A master fire suppression piping contractor, Class A or B, or a master plumber, as restricted, shall be required to post tags at the main control valve and at any closed sectional valves serving areas affected. The tag shall indicate the area affected, a brief description of the condition, the occupancy classification, C of F number and the estimated time until the system becomes operational. Drain test results shall be posted on the tag indicating both the static and flow pressures before and after the system was placed in an out-of-service condition. If no impairment is found in the entire system, green tags will be placed on the main control valve. Systems partially or fully out of service. Systems fully out of service. The impairment coordinator/building owner shall ensure that the local administrative fire company, master fire suppression contractor, Class A or B, or MPs, as restricted, has placed one white disc 8 to 9 inches in diameter on all affected fire department connections. A red tag shall be placed at the main control valve indicating the sprinkler company name, date of removal from service and anticipated return to service date. Systems partially out of service. The impairment coordinator/building owner shall ensure that the local administrative fire company, FSPCs or FDNY units master fire suppression contractor Class A or B has placed one blue disc 8 to 9 inches in diameter on all affected fire department connections. An red tag shall be placed at the main control valve and any closed sectional valve indicating the company name, date of removal from service and anticipated return to service date. The impairment coordinator shall authorize the placement of systems out of service that are planned to be shut down. The impairment coordinator shall notify the certificate of fitness holder about the systems that are out of service. Planned removal from service. The impairment coordinator shall be made aware in advance of any planned removal from service of a standpipe system, sprinkler system or fire alarm system or system component, for repair, servicing, alteration, testing and other maintenance of the system or component, or to allow construction to be performed in the area protected by the system without unnecessarily activating it. The impairment coordinator shall authorize and personally supervise the placing of the fire protection system out of service. Before authorizing the placing of the fire protection out of service, the impairment coordinator shall notify the certificate of fitness holder responsible for supervising the maintenance of the standpipe system, sprinkler system or fire alarm system. Determine the extent and expected duration of the out-of-service condition. Inspect the areas or buildings involved and assess the increased risks. Make appropriate recommendations to the owner. Notify the fire department in accordance with FC 901.7.5, if required. Notify the responsible person designated by the owner to issue hot work authorizations in accordance with FC Chapter 26. Notify the central station and insurance carrier. Notify the occupants in the affected areas if the duration of time the sprinkler system or fire alarm system will be out of service is estimated to be more than 30 minutes. Place a tag at each fire department connection, standpipe and sprinkler system control valve and fire command center, indicating which fire protection system, or part thereof, is out of service. Maintain the fire protection system in service until work is ready to begin. Fire guard. The impairment coordinator or other building staff trained and knowledgeable in conducting a fire watch may conduct a fire watch in lieu of a fire guard during the initial 4 hours of a planned removal from service, or after discovery of an unplanned out-of-service condition, provided that the floor or area in which the fire protection system is out of service does not exceed 50,000 square feet. A sufficient number of fire guards shall be provided such that each floor or area in which the fire protection system is out of service is patrolled at least once an hour. Impaired equipment, underground service mains, water storage tanks, fire department connections, control valves, fire and/or booster pumps, that are out of service and are considered vital to part of the system that are required to be tagged following procedures outlined in Chapter 15 of NFPA No. 25/2011 ed. Tags placed at control valves shall indicate the level of impairment or defect as follows. Tag disc. System fully out of service, red tag, white disc. System partially out of service, red tag, blue disc. System appears free of defects or deficiencies, green tag, no disc. Only FDNY, owner, MFSPC or MP, as restricted, may place a tag on a system. For systems that are fully or partially out of service that are not equipped with fire department connections, the appropriate tags shall be placed at the main control valve. FDNY is to be notified immediately. In a building required by the NYC Fire Code to have a fire safety director with F58 or F25, an engineer, Q01 or Q99, with the S12C of F, is authorized to take the system out of the service for less than 8 hours and place an appropriate colored tag on that system. The FSD and the engineer must be on the premises at all times. Prior to returning a system to service, the impairment coordinator shall ensure that the necessary tests and inspections are conducted to verify that the system is operating normally, notify FDNY borough dispatcher, the building owner's tenants in the affected area, the insurance carrier, emergency preparedness staff, central station operator, if so equipped, and remove out-of-service tags and discs. Protection of sprinkler systems. All parts of an automatic system exposed to freezing temperatures shall be protected from freezing or in lieu thereof. An automatic dry pipe system or a system filled with a non-freezing, non-combustible solution shall be used. When a system filled with a non-freezing solution is used and the system is connected to a potable, drinking, water supply, it shall be subject to the requirements of the Health Department and the Bureau of Water Supply of the Department of Environmental Protection and may require that a backflow preventer be installed. Approved non-freezing solutions include glycerin not greater than 48% and propylene glycol not greater than 38% non-freezing solution. Sprinkler heads subject to damage shall be protected. General procedure for record keeping, impairments, and safety. It shall be the responsibility of the certificate of fitness holder to perform the following. Record keeping. The certificate of fitness holder shall maintain a detailed record of all inspections. Records. Records of all system inspections, tests, servicing and other maintenance required by this NYC Fire Code, the NYC Fire Rules or the reference standards shall be maintained on the premises or other approved location for a minimum of 3 years and made available for inspection by any fire department representative. FC 901.6.2. Detailed records. A detailed inspection report shall include information relative to conditions of water supply, gravity and pressure tanks and levels therein, valves, risers, piping, sprinkler heads and fire department connections, alarms, fire, booster and special service pumps, obstructions, and conditions of all other system equipment and appurtenances. All defects and/or impairments shall be noted on the report. Records shall be readily available to any representative of the fire department. Riser card. In addition to those records required by NFPA 25 as mentioned above, an approved card bearing the dates of each inspection, certificate of fitness number and signature of the certificate of fitness holder shall be posted on the premises near the main water supply control valve. FC 901.6.2.1, this approved card shall not replace or supersede the detailed record of inspection. Notification of all defects shall be reported to the owner or their representative by the certificate of fitness holder. After 30 days, any of the defects that have not been corrected shall be immediately reported to the Fire Department Borough Communication Office. Failure to make inspections, maintain records, and report defects or violations may be cause for revocation of the certificate of fitness and court enforcement proceedings. Individuals authorized to perform tasks as specified in the New York City Fire Code. S12/S15 COF holder, visual inspections only, proper notification and record inspection results for examination by FDNY. S12, water-based fire protection systems. S15, foam water suppression systems and water-based fire protection systems. S12/S15 COF holder employed by a site-specific building owner with the following certifications: Refrigeration Operating Engineer, Refrigeration Q99 or Q01, High Pressure Operating Engineer and NYS High Pressure Operating Engineer are permitted to perform visual inspections, test notification appliances, perform daily and weekly routine maintenance and record all inspection, testing and maintenance results for examination by FDNY. Asterisk, for employees of a single or multiple properties under common ownership employed by the same building owner/management company. Master Fire Suppression Piping Contractor, A or B, MFSPC, with S12/S15 COF, can inspect, test, maintain and repair/replace sprinkler systems components, record maintenance, inspection and test results for examination and evaluation by FDNY. Master Plumber, MP, with S12/S15, is limited to residential, R, occupancies 30 sprinkler heads or less without a booster pump. 6. Definitions. Alarm notification appliance, a fire alarm system component, such as a bell, horn, speaker, light, text display or vibration device that issues an audible, tactile, and/or visual alert. Alarm signal, a signal indicating an emergency requiring immediate action, such as a signal indicative of fire. Antifreeze sprinkler system, a wet pipe sprinkler system employing automatic sprinklers that are attached to a piping system that contains an antifreeze solution and is connected to a water supply. The antifreeze solution is discharged, followed by water, immediately upon operation of sprinklers opened by heat from a fire. Automatic ball drip, an automatic drain valve horizontally installed at the low point in the piping between the lower check valve and the fire department connection of automatic sprinkler systems. Water pressure from a fire department pumper automatically closes this valve. It automatically re-opens when pressure ceases, permitting this piping to drain and thereby preventing freezing. Central station, a facility that receives alarm signals from a protected premises and retransmits or otherwise reports such alarm signals to the department. Combination standpipe and sprinkler system, a system where the water piping services both 2.5 in. 65 mm, outlets for fire department use and outlets for automatic sprinklers. Concealed sprinkler, a recessed sprinkler with a cover plate. Control Mode Specific Application Sprinklers (CMSA). Control mode sprinkler systems are designed to control a fire until its original fuel source is depleted or until firefighting activities can commence. A fire is controlled by cooling the ceiling level air temperatures, reducing the fire's rate of heat release and pre-wetting adjacent combustibles. Control valve, a valve controlling flow to water-based fire protection systems. Control valves do not include hose valves, inspector's test valves, drain valves, trim valves for dry pipe, pre-action and deluge valves, check valves, or relief valves. OS and Y valve, outside stem and yoke valve, is an indicating type of control valve used for fire sprinkler system. Curb valve is a non-indicating gate valve equipped with a cast iron extension box flushed with a sidewalk with an operating nut of 1¼ inch. This valve is operated using a special curb key wrench. This valve controls the municipal water supply serving the fire sprinkler system. Corrosion-resistant sprinkler, a sprinkler fabricated with corrosion-resistant materials, or special coatings to be used in an atmosphere that would corrode standard sprinklers. Deficiency, a condition in which the application of the component is not within its designed limits or specifications. Critical deficiency, a deficiency that, if not corrected, can have an effect on the performance of the fire protection system. Non-critical deficiency, a deficiency that does not have an effect on the performance of the fire protection system, but correction is needed for the proper inspection, testing, and maintenance of the systems. Deluge valve, a water supply control valve intended to be operated by actuation of an automatic detection system that is installed in the same area as the discharge devices. Each deluge valve is intended to be capable of automatic and manual operation. Deluge sprinkler system, a sprinkler system employing open sprinklers that are attached to a piping system that is connected to a water supply through a valve that is opened by the operation of a detection system installed in the same areas as the sprinklers. When this valve opens, water flows into the piping system and discharges from all sprinklers attached. Dry pipe sprinkler system, a sprinkler system employing automatic sprinklers that are attached to a piping system containing air or nitrogen under pressure. The release of the air or nitrogen, as from the opening of a sprinkler, results in the water pressure opening a valve known as a dry pipe valve, resulting in the flow of water into the piping system and out of the fused sprinklers heads. Dry sprinkler, a sprinkler secured in an extension nipple that has a seal at the inlet to prevent water from entering the nipple until the sprinkler operates. May be configured with an upright pendant or sidewall sprinkler. Discharge device, a device designed to discharge water or foam water solution in a predetermined, fixed, or adjustable pattern. Examples include, but are not limited to, sprinklers, spray nozzles, and hose nozzles. Early Suppression Fast Response Sprinkler, ESFR, a type of fast response sprinkler that is listed for its capability to provide fire suppression of specific high-challenge fire hazards. Extra Large Orifice Sprinklers, ELO, a sprinkler head with an orifice size equal to or greater than 1 inch. This sprinkler is used for protection of high-piled storage in warehouses and less pressure is required to achieve a given discharge density. Extended Coverage Sprinklers, a type of spray sprinkler with a maximum area of coverage of 400 square feet, 20 foot by 20 foot spacing between sprinklers, for light hazard occupancies to a maximum of 144 square feet, 12 foot by 12 foot spacing between sprinklers, for extra hazard occupancies. Fire Alarm System, any system, including any interconnected fire alarm subsystem, of components and circuits arranged to monitor and enunciate the status of fire alarm or supervisory signal initiating devices. Fire department connection, a connection, normally on the exterior of the building, through which the fire department can pump supplemental water into the sprinkler system, standpipe or other system furnishing water for fire extinguishment to supplement existing water supplies. Formerly known as Siamese connection. Fire extinguishing system, an approved system of devices and equipment which detects a fire and discharges an approved fire extinguishing agent onto or in the area of a fire. Such term includes automatic systems and, where such systems are authorized by this code or the building code, manually activated systems. Fire hydrant, a valve connection on a water supply system having one or more outlets and that is used to supply hose and fire department connections with water. Fire protection system, approved devices, equipment and systems or combinations of systems used to detect a fire, activate an alarm, extinguish or control a fire, control or manage smoke and products of a fire or any combination thereof, including fire extinguishing systems, fire alarm systems, sprinkler systems and standpipe systems. Fire pump, a pump that is a provider of liquid flow and pressure dedicated to fire protection. A fire pump is a part of a fire sprinkler system's water supply and can be powered by electric, diesel or steam. The pump intake is either connected to the public underground water supply piping or a static water source, example, tank, reservoir, lake. The pump provides water flow at higher pressure to the sprinkler system risers and hose standpipes. A pump used only to fill a tank is not a fire pump. The following fire pumps are required to be maintained in accordance with the NYC Fire Code. Fire pump, automatic standpipe, a fire pump located at or below street level that supplies the lower 300 feet of a standpipe system or a combined standpipe and sprinkler system. Fire pump, foam, a fire pump used to boost water supply pressures in a fire protection system where such system uses firefighting foam as an additive. Fire pump, limited service, a fire pump with a motor rating not exceeding 30 horsepower and utilizing a limited service fire pump controller. Fire pump, special service, a fire pump that is located above street level and that receives its water supply from a gravity tank or suction tank supplying water to fire sprinkler system and/or fire department hose outlets. Fire pump, sprinkler booster pump, a fire pump that supplies sprinkler systems only. Fire pump, water mist system, a fire pump used to boost water supply pressures in a fire protection system where such system utilizes water misting technology. Glass bulb sprinkler, a sprinkler operated by heat breaking a glass bulb filled with a non-freezing liquid with diameters that vary from 3 mm for quick response sprinklers to 5 mm for standard response sprinklers. Hose valve, the valve to an individual hose connection. Hydraulic placard, a sign attached to a hydraulically calculated sprinkler system indicating the design density, required gallons per minute and pressure for the system to operate properly. Hydraulically calculated systems, a method of sizing automatic sprinkler piping using a prescribed amount of water to be distributed over a specific area. Impairment, a condition where a fire protection system or unit or portion thereof is out of order, and the condition can result in a fire protection system or unit not functioning in a fire event. Impairment coordinator, the person responsible for ensuring that proper safety precautions are taken when a fire protection system is placed out of service. Intermediate level sprinkler/rack storage sprinkler, a sprinkler equipped with integral shields to protect the operating element from discharge from sprinklers installed at higher elevations. Large orifice sprinkler, a sprinkler head with an orifice size equal to or greater than 3/4 inch and less than 1. Listed device, a fire protection component that has been tested to perform under parameters specified for its use by a nationally recognized testing agency. Underwriters Laboratory, UL, and Factory Mutual, FM, are the two most common. Master pressure reducing valve, a pressure reducing valve installed to regulate pressures in an entire fire protection system and/or standpipe system zone. Main drain, the primary drain connection located on the system riser and also utilized as a flow test connection. These valves are typically globe pattern valves. Microbiologically induced corrosion, MIC, corrosion caused by the presence of microbes in the water supply that over time attack the interior of metallic piping and cause leaks, pitting, and blockages. Out-of-service system, a fire protection system that is not fully functional, or whose operation is impaired or is otherwise not in good working order. OLD style/conventional sprinkler, a sprinkler that directs 40% to 60% of the water initially in a downward direction and is designed to be installed with the deflector in either the upright or pendant position. Pendant sprinkler, a sprinkler designed to be installed in such a way that the water stream is directed downward against the deflector. Pintle screws, a visual indicating device required for sprinklers manufactured prior to 1999 identifying small orifice sprinklers and large orifice sprinklers where orifice size is different than the nominal thread size of the sprinkler head. Pipe schedule systems, a method of sizing piping based upon the number of sprinkler heads and the occupancy of the protected area. Pre-action sprinkler system, a sprinkler system employing automatic sprinklers that are attached to a piping system that contains air that may or may not be under pressure, with a supplemental detection system installed in the same areas as the sprinklers. Personal supervision, supervision by the holder of a FDNY certificate of fitness who is required to personally present on the premises or other proximate location acceptable to the department, while performing the duties for which the certificate is required. Pressure control valve, a pilot-operated pressure-reducing valve that may be used with a fire or booster pump designed for the purpose of preventing the incoming water supply pressure from dropping below a set pressure. Pressure-reducing valve, a valve designed for the purpose of reducing the downstream water pressure under both flowing, residual, and non-flowing, static, conditions. Pressure relief valve, a valve designed for the purpose of releasing excess air or water pressure from the fire protection piping system. Pressure tank, a tank using air pressure to supplying water for water-based fire protection systems. Tank contents to be maintained at 1/3 air to 2/3 water. Quick response sprinkler head, a sprinkler having a fusible link with a response time index, RTI, of 50 or less. Recessed sprinkler, a sprinkler in which all or part of the body, other than the shank thread, is mounted above the ceiling. Residential sprinkler, a type of fast response sprinkler that has been specifically tested to enhance survivability in the room of fire origin and listed for use in dwelling units. Response time index, RTI, a measurement of the thermal sensitivity of a sprinkler head expressed in meters seconds, 1/2. Sprinkler identification number, SIN, sprinklers manufactured after January 1, 2000 are required to be marked to identify performance characteristics. Supervisory signal, a signal indicating the need for action in connection with the supervision of guard tours, fire extinguishing systems or equipment, fire alarm systems or the maintenance features of related systems. Sidewall sprinkler, a sprinkler having special deflectors that are designed to discharge most of the water away from the nearby wall. Small orifice sprinklers, a sprinkler head with an orifice size smaller than 1/2 inch. Solda link sprinkler, a sprinkler operated by the melting of a metal link. They vary in size and configuration for quick response and standard response sprinklers. The smaller the size of the link, the faster the sprinkler operates. Spray sprinkler, a type of sprinkler listed for its capability to provide fire control for a wide range of fire hazards. The most commonly used sprinkler since 1953. Sprinkler system, a fire extinguishing system, other than a mist fire extinguishing system that utilizes water as the extinguishing agent. Standard response sprinkler head, a sprinkler having a fusible link with a response time index, RTI, of 80 or more. Supervisory signal initiating device, an initiating device, such as a valve supervisory switch, water level indicator, or low air pressure switch on a dry pipe or pre-action sprinkler system, that triggers a supervisory signal. Automatic pressure maintenance device, maintains pneumatic pressure on the piping system set to specific limits by controlling a plant air system, a single air compressor, or a nitrogen supply. Testing, a procedure used to determine the status of a system as intended by conducting periodic physical checks on water-based fire protection systems such as water flow tests, fire pump tests, alarm tests, and trip tests of dry pipe, deluge, or pre-action valves. These tests follow up on the original acceptance test at intervals specified in the appropriate chapter of NFPA No. 25, 2011 edition. Upright sprinkler, a sprinkler designed to be installed in such a way that the water spray is directed upwards against the deflector. Water spray, water in a form having a predetermined pattern, particle size, velocity, and density discharge from specially designed nozzles or devices. Water supply, a source of water that provides the flows, gal/min, bel/min, and pressures, psi, bar, required by the water-based fire protection system. Wet pipe sprinkler system, a sprinkler system employing automatic sprinklers attached to a piping system containing water and connected to a water supply so that water discharges immediately from sprinklers opened by heat from a fire. Water spray fixed system, a special fixed pipe system connected to a reliable fire protection water supply and equipped with water spray nozzles for specific water discharge and distribution over the surface or area to be protected. The piping system is connected to the water supply through an automatically or manually actuated valve that initiates the flow of water. An automatic valve is actuated by operation of automatic detection or manual release equipment installed in the same areas as the water spray nozzles. In special cases, the automatic detection system may also be located in another area. Water tank, a tank supplying water for water-based fire protection systems. System types. Automatic wet sprinkler systems. An automatic wet sprinkler system is an effective fire suppression system. This system discharges water to a localized area that is subject to fire. The sprinkler system is designed to extinguish the fire entirely, or to prevent the spread of the fire. An automatic sprinkler system consists of a series of pipes at or near the ceiling in a building. The sprinkler system is fitted with automatic devices designed to release water on a fire. These devices are called sprinkler heads. The sprinkler heads are normally closed by a disc or cap. This cap is held in place by a heat-sensitive releasing element. A rise in temperature to a predetermined level causes the sprinkler head to open. Water is then discharged in the form of spray. When the sprinkler heads open, they are said to have fused. The sprinkler heads are fitted at standard intervals on the piping. If more than one head opens, the area sprayed by each overlaps that of the sprinkler head next to it. Sprinkler systems are required by law in various occupancies. They also may be installed voluntarily by the owner of the building. The sprinklers are installed to protect the building and its residents. The installation of sprinklers has a major effect in reducing fire losses. About 96% of the fires are extinguished or controlled when sprinklers are installed. The 4% failure was due to a variety of causes including defective piping, closed supply valves, frozen water lines, improper maintenance, and blocked water supply piping. Automatic sprinklers are very effective for preservation of life and property by discharging water to the burning area. Automatic sprinklers also reduce interference with visibility for fire fighting due to smoke. The downward force of the water sprayed from sprinklers lowers the smoke level in the room. The sprinklers also serve to cool the smoke. This makes it possible for persons to remain in the area much longer than they could if the room were without sprinklers. Most standard sprinkler systems have devices that automatically sound an alarm when a sprinkler head discharges water. This alarm is an audible signal at the premise. In many cases they transmit an alarm to a remote location, such as an approved central station company. The central station company monitors the entire fire protection system for water discharge and problems with the equipment. When water discharge is identified, in addition to other actions, the central station company is required to notify the FDNY dispatch. This notification allows the fire department to gain control of a fire as quickly as possible. Water is rarely discharged accidentally from a properly maintained sprinkler system. The most common installation is a wet pipe system. This system has water in the piping at all times. The owner is to ensure that all areas of buildings with water-filled piping are maintained at a minimum of 40 degrees Fahrenheit and are protected from freezing. An example of a typical wet pipe system is shown in the picture on the next page. A typical wet pipe system. Where temperatures drop below freezing, the ordinary wet pipe system cannot be used. Antifreeze sprinkler system. A wet pipe sprinkler system employing automatic sprinklers that are attached to a piping system that contains an antifreeze solution and that are connected to a water supply. The antifreeze solution is discharged, followed by water, immediately upon operation of sprinklers opened by heat from a fire. Antifreeze sprinkler systems are costly and are difficult to maintain. Antifreeze is usually used for small unheated areas. Antifreeze sprinkler systems may be used only in accordance with applicable local health regulations. The freezing point of solutions in antifreeze shall be tested annually by measuring the specific gravity with a hydrometer or refractometer and adjusting the solutions if necessary. Annual testing must be performed in accordance with NFPA 25/2011. Existing cold weather valves, an automatic sprinkler system should not be shut off and drained to avoid freezing during cold weather. However, parts of the sprinkler system may be shut down. Permission must be obtained from the local firehouse. Permission may be given to shut off a maximum of 10 sprinkler heads on a wet pipe system. These shut-off valves are commonly referred to as cold weather valves. These valves are no longer permitted to be installed. Automatic dry sprinkler systems. Dry pipe sprinkler system. A sprinkler system employing automatic sprinklers that are attached to a piping system containing air or nitrogen under pressure, the release of which, as from the opening of a sprinkler, permits the water pressure to open a valve known as a dry pipe valve, and the water then flows into the piping system and out the open sprinklers. Dry pipe sprinkler systems are installed where it is impractical to install a wet pipe system since the protected area cannot be heated to prevent freezing conditions. In most cases the air pressure in the piping is controlled automatically by an air maintenance device. When a sprinkler head is opened by the heat from a fire, the air pressure is reduced in the piping. The drop in air pressure causes a special dry pipe valve to open. When the clapper has opened, the valve is said to have tripped. A supervisory device signals when the valve has opened that will automatically sound an alarm. This alarm is an audible signal at the premise, and in many cases it will transmit an alarm to a remote location, such as an approved central station company. The central station company monitors the entire fire protection system for water discharge and problems with the equipment. When water discharge is identified, the central station company is required to notify the FDNY dispatch. This notification allows the fire department to gain control of a fire as quickly as possible. Water is rarely discharged accidentally from a properly maintained sprinkler system. Sometimes a combination of a wet pipe and a dry pipe system may be used when a part of the building cannot be heated. Higher than normal water pressure and/or water hammer may cause the dry valve to trip accidentally. Water hammer is a condition where a sudden increase in pressure may cause the valve to trip. To reduce this danger, air pressure is usually kept well above the normal trip point. The air pressure is usually set at 15 to 20 psi, pounds per square inch, above the normal trip level. Some valves are specially designed for low pressures. In all cases the manufacturer's instructions regarding pressures to be maintained shall be followed. Quick opening devices. In a dry pipe system there is a delay between the opening of a sprinkler and the discharge of water. This delay may allow the fire to spread and more sprinkler heads to open. The delay is due to the time required for the air leave the sprinkler piping. This difficulty may be partly overcome by the installation of quick opening devices. Quick opening devices when employed must be in operation at all times. Two devices are used to reduce the time needed to open the clapper and allow water into the system. These devices are an accelerator and an exhauster. They are both automatically activated when a drop of 2 psi in air pressure is detected in the system. They quickly change the water and air pressure balance in the system. This change trips the dry pipe valve, allowing the water to force its way through the sprinkler piping in less time. The failure of an accelerator or exhauster to operate will increase the normal tripping of a dry pipe valve. Pre-action sprinkler systems. Pre-action systems are designed for situations where there is danger of serious water damage. Water damage is usually caused by damaged sprinklers or broken piping. Under normal conditions there is no water in the piping. The air in the piping may or may not be under pressure. A pre-action valve prevents the water from entering the system. The valve is automatically opened and a fire detection system discovers that there is a fire or smoke condition. The pre-action valve is tripped by the fire detection system before any of the sprinkler heads open. A supervisory device signals when the valve is opened. The pre-action valve can also be operated manually. The pre-action system has several advantages over a dry pipe system. The pre-action valve opens sooner because the fire detectors react to heat changes faster than sprinkler heads. Fire and water damage may be decreased because water is sprayed on the fire more quickly. The alarm signal is given as soon as the pre-action valve is opened. Heat-responsive devices are commonly used to trip pre-action valves. These devices are also used to activate alarm and supervisory systems. There are three main devices used to trip pre-action valves. 1. Devices designed to operate at a fixed temperature. 2. Devices designed to operate when the temperature in the room increases a set amount in a given time period, rate of rise. And 3. Devices combining fixed temperature and rate of rise devices. Other ways to activate a pre-action valve are smoke detectors, gas detecting systems, hydraulic, electric, manual release, and automatic signals from other safety systems. A supervisory device signals when the valve has opened that will automatically sound an alarm. This alarm is an audible signal at the premise, and in many cases it will transmit an alarm to a remote location, such as an approved central station company. The central station company monitors the entire fire protection system for water discharge and problems with the equipment. When water discharge is identified, the central station company is required to notify the FDNY dispatch. Pre-action system with a recycling feature. A special kind of pre-action system is a recycling system for controlling sprinklers. This system shuts off the water when the fire has been put out or the heat drops. If the fire rekindles or the heat rises sharply, water is discharged again. The system continues cycling on and off as long as the fire persists. Combined dry pipe and pre-action systems, these systems have the basic features of both types of systems. The piping system contains air under pressure. A heat detecting device opens the water control valve and a quick opening device. The system then fills with water and operates as a wet pipe system. If the heat detecting system fails, the system will operate as a standard dry pipe system. 7.4 Deluge Sprinkler Systems. A deluge sprinkler system is equipped with open sprinkler heads designed to wet down an entire area involved in a fire. This system is needed when there is danger of a fire rapidly spreading throughout the building. The deluge system will slow down the spread of the fire. Deluge systems are suitable for hazardous occupancies. This includes buildings in which flammable liquids or other hazardous materials are handled or stored. The sprinkler heads in the deluge system are open at all times. Under normal conditions there is no water in the piping. The air in the piping is not under pressure. A closed control valve prevents water from flowing into the system. A fire detection device automatically opens the control valve when a fire is identified. A supervisory device signals when the valve is opened. When the valve is opened, water flows into the system. The water is then discharged out all of the sprinkler heads. The water control valve may also be opened manually. A supervisory device signals when the valve has opened that will automatically sound an alarm. This alarm is an audible signal at the premise, and in many cases it will transmit an alarm to a remote location, such as an approved central station company. The central station company monitors the entire fire protection system for water discharge and problems with the equipment. When water discharge is identified, the central station company is required to notify the FDNY dispatch. Water supplies for sprinkler systems. Sprinklers may be supplied from one or a combination of sources. For example, they may be supplied by public mains, gravity tanks, pressure tanks, fire pumps, reservoirs, rivers, or lakes. A single water supply would appear to be all that is needed to supply a sprinkler fire protection system. This assumes that there is enough water at an acceptable pressure. However, a single supply may be out of service, for maintenance or repair, during a fire emergency, or it may be disabled during fire or before the fire is fully extinguished. Additionally, the water supply may fall below normal pressure or volume during an emergency. These are just a few reasons why it is good to have a secondary water supply. In some cases it is required by law to have a secondary water supply source. Whether a second source is needed depends on several factors. These factors include the strength and reliability of the primary supply, the value of the property, the height, area, occupancy classification and design of the building. When a sprinkler system is supplied from a public water main, the entire system shall be shut down by closing a non-indicating type control valve. This valve is located between the building and the water main in a box that is recessed into the sidewalk. The location of the box is found by reading a sign on the building or on a post nearby. The sign might read, "Shut off for sprinkler system located 6 feet from this sign," or it may have similar instructions. A special key will be required to operate this valve. Control valves. Gate valves of the non-indicating type are provided in water distribution systems. This type of valve is commonly known as curb valve. Gate valves allow the sprinkler system to be shut off for repairs or maintenance. Such valves are normally a non-rising stem type. They are operated using a special key wrench. A valve box is located over the valve to keep dirt from the valve. The valve box also provides a convenient access point for the valve wrench to the valve nut. A complete record should be made for each valve in the system. This record should include the exact location, the date it was installed, the make, the direction of opening, number of turns to open, and any maintenance that was performed. The control valve for the building may also be on the outside wall or attached to an upright post, known as a post indicator valve, PIV, see image on right. The building or section of the building controlled by the valve is usually marked on the post. The position of this valve, open or closed, is shown through a telltale opening in the post. On some posts, a padlock must first be opened to release the operating wrench or will handle. Sprinkler system control valve signage. A sign identifying the location of the sidewalk box housing the sprinkler system control valve shall be conspicuously posted on the exterior wall of the building directly opposite the sidewalk box. Such sign shall have red letters 1 inch in height on a white background and red, "Sprinkler system shutoff valve," indicate distance, feet opposite this sign, or other approved design. Fire department connections. Normally a sprinkler system is connected to an automatic water supply source. Auxiliary sources of water are supplied through fire department connections at the building. Fire department connections are a standard part of most sprinkler systems. When responding to an alarm, most fire departments supply water to the standpipe system first. The standpipe system supplies water to the fire hoses to be used within the building. Water is then supplied to the sprinkler system through its own fire department connection. Care should be taken that standpipe and the sprinkler connections are properly marked because the connections look the same. The exact purpose of each fire department connection should be shown nearby or on the fire department connection itself. The New York City Building Code requires fire department connection to be color-coded. The fire department connection caps on an automatic sprinkler system shall be painted green. The fire department connection caps on a standpipe system shall be painted red. The fire department connection caps on a combined standpipe/sprinkler system shall be painted yellow. The entire fire department connection to non-automatic sprinkler system shall be painted silver. Local Law 58/2009 requires color coding of fire standpipe and fire sprinkler systems to have the risers, cross connections to the water supply piping painted red, for sprinklers BC 903.6 and for standpipe BC 905.11. Fire department connections must always be accessible. A working space of not less than 36 inches in width, 36 inches in depth and 78 inches in height shall be provided and maintained in front of and around wall-mounted and freestanding fire department connections, except as otherwise required or approved. FC 912.3, each connection shall be fitted with a lower check valve. The lower check valve prevents the backflow of the private water supply into the fire department connection. The figure below shows the main features of a fire department connection. Pressure tanks. Pressure tanks have several possible uses in automatic sprinkler and standpipe systems. The tank is normally kept at 2/3 full of water and 1/3 full of air. The air pressure in the tank shall be maintained at or above 75 psi. Air for pressure tanks is supplied by air compressors. Because the water is always under pressure, it can be forcefully distributed throughout the sprinkler and/or standpipe system. An important limitation is the small amount of water that can be stored in such tanks. Where a small pressure tank is accepted as the water supply, the system is called a limited supply system. Pressure tanks are often used in situations where an adequate amount of water can be supplied by a public or private source but the water pressure is not adequate. The pressure tank gives a strong starting pressure for the first sprinklers or hose valves that open. The flow from the tank may be used while the automatic fire pumps begin to increase the water supply pressure. Pressure tanks are often used in tall buildings that need extra water pressure to supply the highest line of sprinkler heads or hose valves. The pressure tank supplies these devices until the fire department begins pumping water into the system. Pressure tanks are equipped with settling basin at the bottom of the tank to prevent sediment and other foreign materials from entering the sprinkler system. Fire pumps. Fire pumps can be used to boost water pressure and volume for water-based fire protection systems. They may be used in combination with municipal water supply, suction tanks, and gravity tanks to supply sprinkler system. Fire pumps are designed to take the water from a supply source and then discharge the water into the fire protection system under pressure. The amount of pressure with which the water is discharged from the pump is called the total head. The total head is measured in pounds per square inch, psi. The higher the psi rating of the pump, the greater the pressure with which the water can be discharged. Fire pumps shall be sized to satisfy the hydraulic requirements of the water-based fire protection system. Automatic fire pumps must have their suction under a positive head to draw water from a supply source. Under positive head simply means that the water supplying the pump must be fed into the fire pump under pressure. This can be achieved by connecting the fire pump to a suction tank. Water is forced into the pump because of gravity. Water flow alarms and sprinkler system supervision. Sprinkler systems should have devices and equipment for signaling when water flows through risers or mains supplying the systems. The flow may be due to fire, leakage, or accidental rupture of the piping. It is important that prompt action is taken when water flow is signaled by these devices. Functions of alarms and supervisory signals. A sprinkler system with a water flow alarm serves two functions. 1. It is an effective fire extinguishing system, and 2. It is an automatic fire alarm. An alarm is signaled soon after a sprinkler head has opened. This is important since it allows the occupants time to leave the building. It also signals that the fire department should be summoned. Water flow alarms and fire alarms give warning of the actual occurrence of a fire. They also signal when water flows through the system due to broken pipes. Alarms alert occupants and summon the fire department. Any signal, whether water flow or supervisory, may be used to sound an audible local sprinkler alarm. It may also send a signal to the central station company. In systems equipped with central monitored connections, the central station company shall be notified when any control valves are closed for maintenance and repair. This practice reduces false alarms. Sprinkler systems are required to have an approved water motor gong or an electric bell, horn, or siren on the outside of the building. An electric bell or other audible signal device may also be located inside the building. Water-operated devices must be located near the alarm valve, dry pipe valve, or other water control valves in order to avoid long runs of connecting pipe. Devices and equipment supervised. Sprinkler system supervision is commonly provided for several purposes. They are used to supervise 1. Water supply control valves. 2. Low water level in water supply tanks. 3. Low temperature in water supply tanks or ground-level reservoirs. 4. High or low water level in pressure tanks. 5. High or low air pressure in pressure tanks. 6. High or low air pressure in dry pipe or pre-action sprinkler systems. 7. Failure of electric power supply or phase reversal to fire pumps and 8. Automatic operation of electric fire pumps. Water flow alarm valves. The basic design of most water flow alarm valves is that of a check valve which lifts from its seat when water flows into a sprinkler system. This alarm then starts an audible signal to alert the occupants in the building that the sprinkler system has been activated. Vane-type water flow switches have a paddle inserted inside the main supply piping perpendicular to the direction of flow. Upon water flow, the paddle switch transmits an alarm. Vane-type water flow switches shall not be installed to monitor water flow in dry pipe or pre-action sprinkler systems. Pressure-type water flow switches mounted on a trim line. Upon water flow, the switch transmits an alarm. Pressure-type water flow switches are commonly used to monitor water flow in dry pipe and pre-action systems. Alarm retarding devices. An alarm check valve that is exposed to changing water supply pressure needs an alarm retarding device. This is required to prevent false alarms when the check valve clapper is lifted from its seat by a temporary pressure surge. Vane-type water flow switches sensitivity can also be adjusted to changing water pressures. System components. Sprinkler heads. Sprinkler heads are made of metal. They are screwed into the piping at standard intervals. The water is prevented from leaving the sprinkler head by an arrangement of levers and links. The levers and links are soldered together on the sprinkler head. The solder is a metal alloy with a fixed melting point. Other types of sprinkler heads use a glass bulb which expands and breaks under heat. The sprinkler head is factory tested to withstand at least 400 psi without injury or leakage. If properly installed, there is little danger of the sprinkler operating unless it is damaged. There are over 50,000 different variations of sprinkler heads. Sprinklers manufactured after January 1, 2000 are required to have a Sprinkler Identification Number, SIN. Sprinkler heads manufactured prior shall be replaced as required with sprinkler heads of similar characteristics such as orifice size, temperature rating, and deflector orientation. Certain sprinkler heads have been recalled, one of which is called the cycling sprinkler. All sprinkler heads listed for recall and replacement can be found at www.cpsc.gov. Some sprinkler heads are designed to be used in special situations. Sprinkler heads exposed to corrosive conditions are often covered with a protective coat of wax, or lead. Corrosive vapors are likely to make automatic sprinklers inoperative or slow down the speed of operation. They can also seriously block the spray nozzles in the sprinkler heads. They can damage, weaken or destroy the delicate parts of the sprinkler heads. In most cases such corrosive action takes place over a long time. For this reason the sprinkler heads must be carefully watched for signs of corrosion. Care should be taken to make sure that the protective coating is not damaged when handling or replacing the heads. A typical fusible link type sprinkler head is shown as the graph. 4 types of sprinkler heads. 1. Pendant sprinkler heads. Pendant sprinkler is designed to be installed in such a way that the water stream is directed downward against the deflector. This kind of sprinkler hangs from above ceiling pipes and distributes water in a domed or conical pattern using a convex deflector. In other words, these sprinklers are installed with the deflector below the frame so water flows downward from the opening, striking the deflector to create an umbrella pattern. Unlike concealed pendant sprinklers which hide behind decorative plates, the head of a traditional pendant fire sprinkler remains visible after installation. These sprinkler heads are the most common heads for sprinkler systems. When these heads are activated, a stream of water is sent downward onto the deflector, which disperses the water throughout the room. 2. Upright sprinkler heads. Upright fire sprinklers spray water upward to a concave deflector, producing a dome-shaped spray pattern. They install deflector up to cover specific areas and to prevent ice and debris from collecting in the head. Upright sprinklers are installed where obstructions interfere with coverage and in dry pipe systems facing freezing temperatures. 3. Sidewall sprinkler heads. Sidewall fire sprinklers install along walls or beneath beams where ceiling piping is unavailable, or where aesthetic concerns or obstructions weigh against the use of other sprinkler types. Most are designed to protect areas that are tight on space like small rooms, closets, or hallways. Sidewall sprinkler head can spray in a half-circle pattern, which will cover the entire area. Horizontal sidewall sprinklers should only be installed below smooth, flat, horizontal ceilings in accordance with their listings, approvals, and NFPA guidelines. They are used in hotels, restaurants, churches, and a range of commercial structures. 4. Concealed sprinkler heads. Concealed models install in walls or ceilings and fully cover a pendant or sidewall sprinkler head using a concealed fire sprinkler cover plate. This heat-sensitive plate detaches at temperatures roughly 20 degrees lower than the fire sprinkler head, allowing the concealed sprinkler's deflector to drop and the head to activate. The look of fire sprinkler cover plates varies enormously from manufacturer to manufacturer. While most sprinkler heads are available in white, chrome, black, or brass, cover plates are available in a wider range of finishes, including wood pattern, metallic, and, in some cases, custom-painted versions. These fire sprinkler cover plates should never be painted and must always be replaced with the manufacturer's approved plate. Spray pattern of sprinkler heads. The best way to put out a fire is to spray the water from the sprinkler head downward and horizontally. The spray pattern will also prevent the spread of the fire. The force of the water against the deflector creates a heavy spray which is directed outward and downward. The shape of the deflector determines the spray pattern of the water discharged from the sprinkler head. Usually, this is an umbrella-shaped spray pattern. At a distance of 4 feet below the deflector, the spray covers a circular area having a diameter of approximately 16 feet when the sprinkler is discharging 15 GPM. Sprinkler spray patterns must not be obstructed by building components or storage. Standard response and quick response heads. Standard response sprinkler heads. A standard response sprinkler head is a sprinkler having a fusible link or glass bulb with a response time index, RTI, of 80 or more. Standard response sprinkler heads are typically found in warehouses, factories and other commercial or industrial buildings. Quick response sprinkler heads. A quick response sprinkler head is a sprinkler having a fusible link or glass bulb with a response time index, RTI, of 50 or less. Quick response fire sprinkler heads are typically found in light hazard occupancies, e.g. office buildings, schools, healthcare facilities, assisted living facilities, and residential occupancies etc. The use of quick response sprinkler heads may reduce or eliminate the requirements for smoke detection in certain light hazard occupancies. Quick response sprinklers may also be used in storage applications and are called ESFR, early suppression, fast response, sprinklers. Differences between standard and quick response sprinkler heads. Quick response sprinklers got their name from their slightly faster response time when compared to standard response sprinklers. Their only physical difference is the bulb size. The standard response sprinkler has a 5 mm glass bulb and the quick response sprinkler has a 3 mm glass bulb. The smaller bulb has a lower response time index (RTI). 10.2 Temperature ratings classifications and color coding. This chart will be provided when taking this test. Sprinklers shall have their frame arms, deflector, coating material, or liquid bulb colored in according the following table. For a maximum sealing temperature of 100 Fahrenheit degrees or 30 Celsius degree, the temperature rating is from 135 to 170 Fahrenheit degree or from 57 to 77 Celsius degree. The temperature classification is ordinary, the frame color code is uncolored or black and the glass bulb color is orange or red. For a maximum sealing temperature of 150 Fahrenheit degrees or 66 Celsius degree, the temperature rating is from 175 to 225 Fahrenheit degree or from 79 to 107 Celsius degree. The temperature classification is intermediate, the frame color code is white and the glass bulb color is yellow or green. For a maximum sealing temperature of 225 Fahrenheit degrees or 107 Celsius degree, the temperature rating is from 250 to 300 Fahrenheit degree or from 121 to 149 Celsius degree. The temperature classification is high, the frame color code is blue and the glass bulb color is blue. For a maximum sealing temperature of 300 Fahrenheit degrees or 149 Celsius degree, the temperature rating is from 325 to 375 Fahrenheit degree or from 163 to 191 Celsius degree. The temperature classification is extra high, the frame color code is red and the glass bulb color is purple. For a maximum sealing temperature of 375 Fahrenheit degrees or 191 Celsius degree, the temperature rating is from 400 to 475 Fahrenheit degree or from 204 to 246 Celsius degree. The temperature classification is very extra high, the frame color code is green and the glass bulb color is black. For a maximum sealing temperature of 475 Fahrenheit degrees or 246 Celsius degree, the temperature rating is from 500 to 575 Fahrenheit degree or from 260 to 302 Celsius degree. The temperature classification is ultra high, the frame color code is orange and the glass bulb color is black. For a maximum sealing temperature of 625 Fahrenheit degrees or 329 Celsius degree, the temperature rating is 650 Fahrenheit degree or 343 Celsius degree. The temperature classification is ultra high, the frame color code is orange and the glass bulb color is black. In places where the temperature is normally high, e.g. boilers, ovens and drying rooms, a sprinkler head with a higher temperature rating must be used. This is to make sure that the sprinkler head does not discharge water at the wrong time. If heads with a high temperature rating are used in ordinary room, example an office, an apartment, and store, the value of the sprinkler protection is greatly reduced. This is because the temperature will have to increase much higher for the sprinkler heads to open. Sprinkler systems are excellent for controlling fires. However, they can cause water damage if they are not shut down soon after the fire has been extinguished. No control valve on the system should be closed except on the order of the fire officer in charge. If the fire has been completely extinguished, the building owner or their representative may close the control valve. Sometimes the fire department has a difficult time finding the control valve to shut down the system. This problem can be prevented by keeping a small sketch of the sprinkler system and the position of the control valves. This sketch should always be readily available. This sketch is very helpful to the firefighters when they are responding to an affected premise. Buildup of foreign material on sprinklers. Sometimes conditions exist which cause a buildup of foreign material on sprinkler heads. This may prevent the sprinkler head from working properly. This buildup is commonly called loading. The buildup of foreign material insulates the sprinkler head. This buildup prevents the sprinkler from opening at the desired temperature. If the buildup is hard, it may prevent the sprinkler from opening. Replace loaded sprinkler heads with new sprinkler heads rather than attempting to clean them. If the deposits are hard, attempts to clean the heads are likely to damage them. This damage may prevent the sprinkler heads from working properly. The damage may also cause the sprinkler head to leak. Deposits of light dust are less serious than hard deposits. Dust buildup may delay the operation of sprinkler heads. However, it will not prevent the eventual discharge of water. Dust deposits can be removed using compressed air or a vacuum, provided the equipment does not touch the sprinkler. Removal of protective caps and straps on glass bulb sprinklers shall be performed at the time of installation. Spare sprinkler heads. Sprinklers required for emergency replacement must be representative of the type of sprinklers installed along with the proper wrenches. These wrenches shall be provided in the spare head cabinet. It is critical sprinklers be replaced with devices that will perform similarly to the original system sprinklers. Sprinklers that are replaced during an emergency by unlicensed individuals require that the devices used have been verified appropriate for the protected area by a master fire suppression piping contractor. After activation by fire, sprinkler heads in close proximity to the affected area should be visually inspected and replaced, if required. A stock of spare sprinklers, not less than 6, shall be kept on the premise where the temperature does not exceed 100 degrees Fahrenheit and shall include all types and ratings installed in the protected facility and provided as follows. For under 300 sprinklers room, 6 spares of sprinklers. For 301 to 1000 sprinklers room, 12 spares of sprinklers. For over 1000 sprinklers room, 24 spares of sprinklers. Pressure tanks. Pressure tanks are enclosed water tanks of limited size. Air pressure in the tank permits forceful discharge of water in the tank into the sprinkler system. A pressure tank may be used as a primary or secondary water supply for a sprinkler system. A pressure tank is usually housed in an enclosed structure. The temperature in the enclosure is kept at 40 degrees Fahrenheit or above. Pressure tanks are to be maintained at approximately 2/3 full of water and 1/3 full of pressurized air. The minimum acceptable air pressure inside the tank is 75 psi, pounds per square inch. The air pressure in the tank may be automatically maintained by an air compressor. The maximum gross capacity of pressure tanks is 9,000 gallons. Some sprinkler systems require more than 6,000 gallons of water. When this occurs, several pressure tanks are used in combination to supply the system. A standard pressure tank is shown in the sectional diagram below. Standard pressure tank. Pressure tank alarms. All pressure tanks used to provide the required primary water supply for a sprinkler system shall be equipped with 2 high and low alarm systems. One system monitors the high and low air pressure. The other system monitors the high and low water levels. The alarm system automatically monitors the air-to-water volume ratio, which should always be 1, air, to 2, water. An alarm signals the certificate of fitness holder or central station operator when the water level or the air pressure is too high or too low. When this occurs, the pressure tanks shall be adjusted or repaired immediately. Supervision of the pressure tank. The pressure tank may also be supervised by an approved central station company which monitors the entire sprinkler system. Supervisory devices are installed in the pressure tank. These devices alert the central station company when there is a problem with the tank's water level, air pressure, and water temperature. The devices also alert the central station company when water has been discharged from the tank. When sprinkler heads have fused and water has been discharged from the tank, the borough dispatcher is notified. The central station company notifies the owner or the impairment coordinator when a problem is caused by an equipment failure. Repairs and adjustments shall be made quickly to return the pressure tank to good working order. Gravity tanks. Gravity tanks are used for water storage. They are made of wood, steel, concrete or fiberglass. Gravity tanks are used as a primary or secondary water supply source for sprinkler systems. A gravity tank system delivers water from the tank through the sprinkler system without the use of pumping equipment. A gravity tank should be at least 25 feet above the highest line of sprinkler heads that it supplies. Tanks may be located on the tops of buildings or raised on tall supporting towers. Examples of a typical gravity tank are shown below. A typical gravity tank. The water pressure in a gravity tank system depends on the elevation of the tank. This is the main advantage over other kinds of systems. For every 1 foot the tank is above the discharge outlet 0.433 psi, pounds per square inch, of water pressure is generated. In other words, the higher the tank elevation, the greater the water pressure. The gravity tank is extremely reliable. It does not depend on the operation of mechanical equipment to supply the sprinkler system. Automatic fill pumps supply the water to most gravity tanks. The pumps fill the tank at a rate of 65 GPM, gallons per minute, or more. The floats turn on the fill pump when the water in the tank is too low. The floats shut off the pump when the desired water level is reached. The floats make sure the gravity tank always has the right amount of water to supply the sprinkler system. All gravity tanks have an overflow pipe that drains off excess water in the tank. This happens if the floats do not turn off the fill pump. A fill pump is not necessary if the water pressure in the city water main is able to keep the tank filled with the correct amount of water. Gravity tanks are exposed to very low temperatures. All parts of the gravity tank must be insulated or heated to keep the water from freezing. Several methods are used to heat the tank and a pipe that supplies the water. 1. Hot water is circulated by gravity. 2. Steam is discharged directly into tank. 3. Steam coils are placed inside the tanks. 4. Heat from the sun is used. The certificate of fitness holder can find out the temperature of the water by using a thermometer. The thermometer is located near the heating device. Severe damage can occur to the piping and the tank if the water inside the tank freezes. During freezing weather, the temperature of the water inside the tank and the riser must be checked daily or weekly. The temperature of the water shall always be at least 40 degrees Fahrenheit. Ice should not be allowed to build up on the gravity tank. The extra weight of the ice might weaken the supports of the tank and cause the tank to collapse. Falling icicles may also cause damage or injury. It is essential to be sure that the tank is properly heated, insulated and carefully maintained. The gravity tank must always have a full supply of water. A full tank of water is needed to ensure the sprinkler system works properly during a fire. Keeping the tank full of water also prevents wooden tanks from shrinking. A full tank of water helps keep steel tanks from rusting. Gravity tank supervision. The gravity tank shall be constantly monitored to ensure that the tank and its parts are working. Electrical supervision devices monitor the water temperature and the water level in the gravity tank. These devices send signals to an approved central station company about the water level and water temperature. The central station company notifies the owner or the impairment coordinator when a problem with the gravity tank is detected. The owner shall correct the problem as soon as possible. The supervisory devices are sometimes called high and low alarms since they also send audible signals to alert the owner or impairment coordinator or central station when there is a problem. The main reason a sprinkler system supplied by a gravity tank fails during a fire is because there is not enough water in the tank. The sprinkler system cannot be supplied if there is not enough water in the tank. A proper water level shall be maintained. Fire pumps. The centrifugal pump. The centrifugal fire pump is the standard pump currently used in fire protection systems. This is the preferred pump because it is reliable, compact, requires low maintenance, and it can be powered by a variety of drivers including electric motors, diesel engines, and steam turbines. A typical centrifugal pump is shown in the diagram below. Principle of operation. The water available to the centrifugal pump must always be under pressure because the pump is not designed to lift water for the supply source. A water tank can be used if the tank supplies the pump due to gravity. In other words, the weight of the water forces the water to flow into the pump. This type of water tank is called a suction tank. The water flows from tank through the supply inlet into the pump. As the water passes to the center of the pump, it reaches a rotating impeller. This impeller is designed to grab the water on the inlet side of the pump and then discharge the water under increased pressure and flow into the fire protection system. Depending on the model, centrifugal pumps are capable of discharging water from 25 GPM, gallons per minute, up to 5,000 GPM. Most centrifugal pumps have a single impeller and are therefore commonly called single-stage fire pumps. The vertical turbine pump. A vertical turbine pump is really a modified centrifugal pump that has the capability to draw water from streams, ponds, wells, etc. Unlike the standard centrifugal pump, the vertical turbine pump does not need the suction supply to be under pressure for it to operate. Instead, it draws the water into the pump by suction. When it reaches the rotating impellers, the water pressure and flow are increased and then forcefully discharged into the fire protection system. Although the vertical turbine pump is capable of drawing water from wells, it is generally not recommended to use a well as the main water supply source because it may dry up without warning. Should the well dry up, it would make the turbine pump useless. It is better to draw water from the well and to fill a water storage tank. A fire pump should then be attached to a more reliable supply source such as storage or suction tank. When using a pump to draw water from a suction supply source, it is important to ensure the water intake hose, foot valve, and screens are inspected regularly. Mud, gravel, leaves and other debris may cause damage to the pump or obstruct the sprinkler system piping. A vertical fire pump arrangement using a water reservoir is shown below. Pump activation. Fire, booster or special service pumps supplying fire sprinklers are started automatically when there is a drop in water pressure in the system. Minor drops in water pressure are maintained by a pressure maintenance pump. When the drop of pressure in the system is greater than the capacity of the pressure maintenance pump, the pump is activated. When manually activated fill pumps are installed, they may be used in combination with a gravity or a pressure tank. These tanks are designed to operate when there is a pressure drop in the fire sprinkler system. The operation of the pressure tank and the triggering of its supervisory devices send a signal to a local alarm point in a building and may alert a central station monitoring company. After the alarms have sounded, the certificate of fitness holder is required to refill the gravity and/or pressure tanks manually. Sometimes remote push buttons are used to activate the pump. These remote push buttons are designed to start the pump but not to stop the fire pump. Many fire pump controllers are manufactured with maximum run timers that automatically turn the fire pump off if an upper pressure limit has been reached. As per the FDNY Commissioner, these timers must be disabled for all automatic fire pumps in NYC. Pressure maintenance pumps, jockey pumps, pressure maintenance pumps, sometimes referred to as jockey, or makeup pumps, are often found on sprinkler systems. These pumps are designed to automatically operate when there is a slight drop in pressure due to leakage in the system. The jockey pump restores the pressure in the fire protection system to the desired level. When the drop of pressure in the system is greater than the capacity of the jockey pump, the fire pump is activated. Because this pump is considered a convenience pump and does not supply flow or pressure during the event of a fire, it does not require inspection, testing or maintenance as per NFPA 25 or the NYC Fire Code. Booster pumps. Booster pumps are used in sprinkler systems. These pumps are usually located in the basement. The booster pump is used when the water pressure available at the highest sprinkler head does not meet the demands of the sprinkler system. This pump increases the water pressure in the sprinkler system until it reaches acceptable levels. The booster pump should not be confused with pressure maintenance pumps, jockey pumps. Booster pumps shall be maintained according to NFPA 25 standard for fire pumps. Special service pumps. Special service pumps are sometimes used in sprinkler and standpipe systems. These pumps are small pumps with limited power taking suction from gravity tanks. These pumps are used when the water pressure available does not quite meet the needs of the sprinkler/standpipe system. This small pump increases the water pressure and volume in the sprinkler/standpipe system until it reaches acceptable levels. The special service pump should not be confused with pressure maintenance pumps, jockey pumps. Special service pumps shall be maintained according to NFPA 25 standard for fire pumps. Operation and supervision. When fire pumps are activated by electric automatic controllers, it is essential that they are constantly monitored to ensure the availability of the electrical power supply in case of an emergency. For this reason, supervisory devices are installed on the pumps that alert the certificate of fitness holder and/or a central monitoring station when there is an electrical power failure. In cases where steam turbines or internal combustion engines are used, similar supervisory devices are installed to signal when there is a problem with the controlling equipment. Fire pump location. The fire pump should be housed in a room that is fire-resistant or constructed non-combustible material. The pump room should be located as close as possible to the fire protection system. The pump room should be kept clean and accessible at all times. The fire pump, driver, and controller should be protected against possible interruption of service. The temperature inside the pump room should be maintained above 40 degrees Fahrenheit at all times to prevent freezing of the water. The pump room should only be used for fire protection functions and not for general plant operations. No storage is permitted in this room. Hanging, bracing and restraint of sprinkler system. Piping. The structural support of the sprinkler system plays an integral part of system reliability. Missing or defective pipe hangers can cause the entire system to fail from piping rupturing or leaking. Great care and experience must be applied in evaluating the adequacy of the structural support of the system. Piping shall be supported from the building structure in accordance with the NYC Code requirements and NFPA No. 13, 2007 edition. The annual visual inspection of system hanging components and bracing is the most complicated and difficult of all the tasks to be performed by the C/F holder. This reference is a starting point and by no means does it fully explain the various means, methods, and requirements to adequately perform this annual inspection task. Chapter 9 of the NFPA No. 13 2007 edition describes in great detail the fundamentals of hanger design and installation and should be used as a reference guide for accurate inspection results that will be reported to the owner and FDNY. There are any numbers of different deficiencies that may be found during the inspection process. They may include system supports being disturbed by the movement of adjacent equipment, deflection or sagging of the building structure, deterioration of the portion of the structure used to support the system and attaching excessive loads to hanging components or piping. Unapproved or makeshift hangers such as perforated strapping or baling wire are prohibited. Nails shall not be used to fasten the system or building attachments to the structure. Hangers used with plastic piping must be listed for use with the piping material. A visual inspection of the system is performed from the floor to determine if the hangers, bracing and restraints are in place and if the piping has moved from its original location and position. This can be observed if the hanger rods or piping attachments are not being supported adequately from the building, bent, misaligned, loose or missing. Shifting of the system may occur during pressure surges, water hammer, alterations, testing, or operation. The visual inspection of hanging and bracing for sprinkler systems is not required for piping concealed by building construction above ceilings and in concealed spaces. When there is an indication of concealed piping system sprinklers heads either too far above or below a hung ceiling, further investigation is required to determine if hangers and supports are defective or missing. No other components shall be supported using the sprinkler system piping or hanger assemblies supporting the system. There are many variations in hanger assemblies and a few common types illustrated below. A brief overview of piping and support fundamentals. Sprinkler system piping is categorized as follows. Branch lines are directly connected to sprinkler heads. Cross mains or loop mains are directly connected to branch lines. Feed mains are directly connected to cross mains or loop mains. Risers are able to supply feed mains or cross mains directly. The vertical supply pipes in a sprinkler system. The spacing of hangers varies with the material and diameter of the piping, the location of piping connections, ability of the structure to support the piping, the location of the piping in relation to the building structure, and system the attachments. Hangers generally consist of an attachment to the piping, an attachment to the building structure, and a ferrous rod attaching the components together. Hanging components are generally required to be listed devices, however, a licensed professional engineer may also certify that a hanger or hanging assembly may be used. A partial list of specific hanger spacing requirements is noted below. Standard wall steel pipe with diameters 1 inch and 1 1/4 inch are required to have hangers placed at a maximum of 12 feet apart. For all other pipe diameters the maximum distance between hangers is 15 feet. The maximum hanger spacing for threaded light wall steel pipe shall not exceed 12 feet apart. The maximum hanger spacing for CPVC, plastic, pipe varies from a maximum 5 feet 6 inches for 3/4 inch piping to a maximum 10 feet on center for 3 inch. There are extensive additional hangings and bracing requirements for CPVC piping, and the installation and design manuals for this product must be referenced to perform adequate visual inspections required by the standard. The distance for the hanger assembly to the centerline of an upright sprinkler head shall not be less than 3 inches. Hangers placed closer to sprinklers will cause an obstruction to the discharge pattern. For systems operating at less than 100 psi, the unsupported length between the end sprinkler head and the last hanger on the line shall not exceed 36 inches for 1 inch piping, 48 inches for 1 1/4 inch piping, and 60 inches for piping 1 1/2 inch or larger. For systems operating at pressures of 100 psi or greater, the hanger closest to the last sprinkler on the line shall be of the type that prevents the upward movement of the piping within the hanger assembly. This can be accomplished by the use of a surge restrainer. The cumulative length of an unsupported arm over to a sprinkler head, sprinkler drop, or sprinkler sprig up shall not exceed 24 inches for steel pipe and 12 inches for copper pipe. System risers, vertical piping passing from floor to floor, shall be supported with riser clamps and hangers located within 24 inches of the centerline of the riser. The distance between supports for risers shall not exceed 25 feet. The minimum size hanger rods are required as follows. For pipe diameter up to and including 4 inches, 3/8 rod diameter in inches. For pipe diameter 5, 6 and 8 inches, 1/2 rod diameter in inches. For pipe diameter 10 and 12 inches, give 1/8 rod diameter in inches. Seismic restraints. The NYC Building Code adopted earthquake code requirements. This reclassification requires the installation of sway bracing for earthquake protection be installed on sprinkler systems in buildings built after 1998. The system piping shall be braced to resist both lateral and longitudinal horizontal seismic loads and to prevent vertical motion resulting from seismic events. Lateral braces shall be spaced at a maximum of 40 feet on centers and are required on all piping 2.5 inch and larger. The distance from the last brace to the end of the pipe being braced shall not exceed 20 feet for systems constructed under the 2008 Building Code. The distance from the last brace to the end of the pipe being braced shall not exceed 6 feet for systems constructed under the 2014 Building Code. Longitudinal braces shall be spaced at a maximum of 80 feet on centers and are to be provided on feed and cross mains. Piping shall be protected against damage where subject to earthquakes by the use of flexible couplings for piping 2.5 inch and larger. Flexible connection shall also be provided at building expansion joints, and within 24 inches of top and bottom of the piping dropping down to in-rack sprinklers and mezzanines regardless of pipe size. To avoid damage to piping passing through holes in platforms, walls, floors and foundations, a clearance of at least 2 inches shall be provided around the piping and the penetration. If this is not provided, flexible couplings shall be provided within 1 foot on both sides of the wall, floor, beam openings or platforms. Risers exceeding 3 feet in length shall be equipped with a 4-way brace with distances between braces not to exceed 25 feet. All parts of bracing and fittings attaching bracing to the piping shall lie in a straight line to avoid uneven loading of fittings and fasteners. Examples of seismic restraints are shown below. Inspection, testing and maintenance frequencies. Inspection and maintenance of pressure tanks. The water level and air pressure in pressure tanks shall be inspected and maintained in accordance with NFPA No. 25, 2011 edition. The water level and air pressure must provide an adequate water supply to the sprinkler system. The capacity of the compressor shall be sufficient to build up the tank pressure to 75 sig within 3 hours or less. The water gauge valve shall be opened to examine the water level. When the valve is opened, the water will flow into the gauge. This allows the certificate of fitness holder to compare the water level in the tank to the desired water level mark. Adjustments to the water level should be made as needed. After visually inspecting the water gauge valve, the valve should be closed. When the valve is closed, the water and air in the tank are isolated from the sight glass. If the gauge glass breaks, the volume of water and the air pressure are not affected. The inside of pressure tanks shall be inspected carefully in accordance with NFPA 25, 2011 Table 9.1.1.2. Rusting in the tank may require repainting or other repairs. The inside of the tank should be thoroughly scraped, wire brushed and repainted. No foreign materials should be allowed to fall into the sprinkler system. The temperature inside the structure housing the pressure tank should be checked daily during cold weather to make sure that the temperature is at least 40 degrees Fahrenheit at all times. Inspection and maintenance of the gravity tank. The gravity tank shall be regularly inspected and maintained in accordance with NFPA No. 25, 2011 edition. Maintenance is needed to be sure that the tank functions correctly. Tanks are to be painted regularly to prevent rusting. Before the inside of a gravity tank is repainted, the surface should be thoroughly dried. All loose paint, rust, scale, and other surface contamination should be removed. The outside of the gravity tank will require local patching. A complete finish coat of paint is needed when the paint has weathered thin. A new coat of paint also improves the appearance of the tank after it has been patched. Painters shall be careful that scrapings or other foreign materials do not fall down the outlet into the sprinkler piping. The discharge outlet shall be covered for protection during repairs. Only a few sheets of paper or a paper bag tied over the end of the settling basin stub should be used. The paper shall be removed immediately after the job is finished. It is best if gravity tanks are used only for fire protection and for no other purpose. Tanks used for other purposes need to be refilled more often. The FDNY Borough Dispatcher shall be notified when a tank cannot be used for any reason. Pump inspection and maintenance. In order to ensure the reliable operation of the pump in the case of an emergency, regular inspections and maintenance shall be conducted by the certificate of fitness holder. The pump shall be activated as indicated in the reference guide and run for 10 minutes in accordance with the manufacturer's specifications. When the pump is in operation, a small water leak on the pump bearings is desirable and should not be considered a malfunction. Additionally, water should discharge from a circulation relief valve, electric pump, or heat exchanger, diesel pump, while the fire pump is operating under a no-flow condition. If an automatic controller operates the fire pump, the pump shall be activated by reducing the water pressure in the system. This can be done by opening the test drain or initiating a large water flow from the system. By starting the fire pump this way, the certificate of fitness holder can determine if the automatic controller is working properly. Care shall be taken to make sure that the pump does not overheat while conducting the test. The centrifugal pump relies on the water supply for cooling and lubrication and shall never be operated without the pump being supplied with water. A visual inspection of all parts of the pump and the controlling equipment shall also be conducted in accordance with the reference guide. This inspection includes the condition and reliability of the power supply. If any problems are discovered with the equipment, immediate action shall be taken to correct the problem. Fire, booster and special service pumps shall be fully tested annually to make sure that the pump, driver, power supply and all other parts are functioning properly. Common deficiencies. Common deficiencies. The most common sprinkler system deficiencies include painted or loaded sprinkler heads, building contents located less than 18 inches below sprinkler deflectors, changes from the original wall locations, ceiling heights, and positioning of mechanical equipment. For concealed sprinkler systems, cover plates with non-factory coatings and the lack of required gap between cover plate and ceiling and blocking of the spray patterns from light fixtures close to the sprinklers are the most common deficiencies seen in the field. Missing trim or cover plates not attached properly to sprinklers may indicate hanger deficiencies and may not allow the sprinkler deflectors to drop below the ceiling, blocking the spray pattern. The C of F holder shall assume that the system being inspected is installed in accordance to the NYC building code in effect at the time of installation. The C of F holder is to report those items of change that impact the system components regarding compliance with any retroactive requirements, the condition of the water supply control valves, water and air levels in tanks and condition of same, unusual changes in water supply or system pressures, condition and accessibility of control valves, fire department connections, clearance around sprinkler heads, accessibility of curb valve box, system control valves, required signage, attachments to piping other than system components, misaligned piping due to impact, missing pipe hangers and supports, excessive operation of pressure relief valves, easily recognized recalled sprinkler heads and visible leakage. Factors that may require further investigation, installations that don't appear to be correct including sprinkler heads located more than 22 inches below the ceiling or structure, sprinklers not installed in accordance with their listing, using sprinklers with different RTI in the same protected area or the wrong RTI for the occupancy classification, undersized piping, incompatible piping materials, flexible sprinkler hoses not attached to the building structure, along with areas of the building not protected by the sprinkler system all require further investigation by a qualified MFSPC. When sprinklers are replaced, the following information is critical to be certain that the correct devices have been used. Sprinklers with different diameter glass bulbs will have a different RTI and must not be used together in the same compartment. Defective sprinklers without SIN identification shall be replaced with devices that perform a similar function. They shall have the same RTI, temperature rating, discharge pattern and orifice size. Residential/hotels Group R, J in pre-2008 code, residential sprinklers are required in all sleeping compartments. Quick response sprinklers are required in all other portions of the facility. Business/Office Group B, E in pre-2008 Code, Institutional I, H in pre-2008 Code, Education E, G in pre-2008 Code, require quick response sprinklers be installed in all occupied areas. Glass bulb sprinklers are sensitive to damage and are required to be shipped from the factory with protection. The orange caps and straps need to be removed prior to putting the system in service. The sprinkler will fail to operate with these devices in place. Local Law 58 of 2009. Fire suppression piping components to be identified as required by Local 58/2009. Note, only existing visible piping shall be identified as required. When ceilings are removed during renovations, any existing visible system piping shall be identified and painted. Standpipe and sprinkler feed mains, the portion of the standpipe or sprinkler system piping that supplies water to one or more standpipe or sprinkler risers. Standpipe and sprinkler cross connections, the portion of the standpipe or sprinkler system that interconnects the feed mains and risers to the fire department connections. Standpipe and sprinkler risers, the vertical portion of the system piping that delivers the water supply for hose connections, and sprinklers on standalone as well as combined systems, vertically from floor to floor. Fire department connections, the portion of the standpipe or sprinkler system that is connected to the fire department pumper connection supplies the standpipe and sprinkler feed mains, cross connections, and risers. All handles of indicating valves, these handles controlling the water supplies to the standpipe and sprinkler systems. Street water supply, the portion of system piping connected to the discharge of the water meter to the main sprinkler control valves. All pipe material identification information, if present, shall not be painted. Fire suppression piping components not required to be identified as required by Local 58/2009. Fire department hose valve bodies and handles, indicating control valve bodies, check valves, jockey pump control valves, trim, test, and drain valve handles. Standpipe branch piping, the portion of the piping system connecting one or more hose valve stations. Sprinkler cross mains, the portion of the piping system connecting supplying the branch lines either directly or through risers. Sprinkler feed mains, the portion of the piping system downstream of a sectional or floor control valve supplying cross mains. Sprinkler branch piping, the portion of the piping system to which the sprinkler heads or nozzles are directly connected to. For more info go to the attached URL, NYC Building website Local Law 58/2009, http://www.nyc.gov/html/dob/download/pdf/ll58 of 2009.pdf. Obstruction investigation. Obstruction investigation. The presence of obstructions in sprinkler systems shall be checked every 5 years by opening a flushing connection at the end of one main per system. One sprinkler head per system toward the end of one branch line shall also be removed. This is done for investigating for the presence of foreign organic or inorganic material. Sources of obstructions to piping include but are not limited to pipe scale, careless installation or repair, raw water sources, biological growth, sprinkler calcium carbonate deposits and microbiologically influenced corrosion, (MIC). Inorganic material would include but not be limited to silt, sand, rocks, gravel, and construction debris. Organic material includes wood, microbes, and zebra mussels. While zebra mussels not reported in the NYC area, the Hudson River contains this predator, and it is possible contamination may occur in NYC's upstate water supplies. http://www.nyc.gov/html/dp/html/press_releases/97-45pr.shtml. When tubercules and slime are found during the investigation, they shall be tested for MIC. An obstruction investigation shall also be performed whenever the following conditions exist, such as pinhole leaks, a record of broken public water mains in the vicinity, foreign material in water discharged during drain tests, or plugging of inspector's test valve connection. A complete list of system conditions requiring obstruction investigation are listed in Chapter 14 and Annex D of NFPA No. 25 2011 edition. Foam Water Fire Suppression Piping System. Introduction. For years, foam has been used as a fire extinguishing medium for flammable and combustible liquids. Unlike other extinguishing agents, water, dry chemical, CO2, etc., a stable aqueous foam can extinguish a flammable or combustible liquid fire by the combined mechanisms of cooling, separating the flame/ignition source from the product surface, suppressing vapors, and smothering. It can also secure for extended periods of time against reflash or reignition. Water, if used on a standard hydrocarbon fuel, is heavier than most of those liquids, and if applied directly to the fuel surface, will sink to the bottom, having little or no effect on extinguishment or vapor suppression. If the liquid fuel heats above 212 degrees Fahrenheit, the water may boil below the fuel surface, throwing the fuel out of the contained area and spreading the fire. Foam extinguishing systems. Foam fire extinguishing systems shall be periodically inspected, tested, and otherwise maintained in accordance with information described in this study material, as well as NFPA 25, 2011, NFPA 11, 2005, as modified by Fire Code Appendix B, and NFPA 16, the standard for installation of foam, water sprinkler and foam water spray systems, 2007, as modified by Fire Code Appendix B, and manufacturer's listing. These systems are used primarily for property protection and may be operated both manually and automatically to protect both Class A and Class B hazards using low expansion foam. Foam is very effective and is the most common method of fighting fires in fuel oil storage. Foam is created by mixing a 3% foamite concentrate with water and air. The foam is designed to smother the flame and prevent reignition. Fixed foam generating systems automatically control the water and foam concentrate mixture. Foam types are subdivided into three ranges. 1. Low expansion foam uses foam to solution volume ratios up to 20:1. 2. Medium expansion foam uses foam to solution volume ratios from 20:1 to 200:1. 3. High expansion foam use foam to solution volume ratios from 200:1 to approximately 1000:1. It is important to note that different foam manufacturers may not produce foam solution that is compatible with each other. Great care must be exercised when testing and maintaining these systems to be certain that all the equipment is listed to be used together. Foam water sprinkler systems and foam water spray systems use low expansion type foams and are connected to a source of foam concentrate and an automatic water supply. The water supply system is activated by detection devices in the same area the sprinklers or discharge nozzles are located. When the control valve operates, the water flows into the system piping and foam concentrate is injected into the water, producing a foam solution that discharges for a specified duration through all open sprinklers or nozzles. In order to provide extinguishment of the fire, these systems must be designed using the proper discharge devices, pipe sizes, water pressure and flow rates, along with the correct type and volume of foam concentrate, along with the appropriate mixing mechanism required to extinguish the fire. The method of fire extinguishment is by covering the fuel, cutting off the oxygen supply to the fire along with cooling the fuel due to the water content of the mixture. Foam water systems may also be used in fire prevention by covering the surface of a flammable or combustible liquid spills to contain the vapors that are subject to ignition. Foam solutions are not an effective extinguishment agent for fires involving compressed gases, flammable metals, or electrical fires due to the water contained in the mixture. Foam solutions do have the potential to pollute water supplies, and great care should be taken to contain foam solution runoff where applicable. When possible, foam concentrate shall be recycled back into the storage tank during the maintenance procedures. Inspection. The inspection of water-based foam fire suppression piping systems may be performed by a valid S15 COF holder. Testing and maintenance. The testing and maintenance of water-based foam fire suppression piping systems shall only be performed by a licensed MFSPC, Master Fire Suppression Piping Contractor, with a Class A license and a valid S15 COF. Installation. The installation of the water-based foam fire suppression piping systems shall only be performed by a licensed MFSPC, Master Fire Suppression Piping Contractor, with a Class A license. Initial installation and periodic performance testing. Foam fire extinguishing systems shall be subject to acceptance tests as contained in the installation standards set forth in NYC Fire Code and the NYC Fire Rules. When a discharge test is not required by the installation standard, the Fire Commissioner may require such test when there is evidence that the system will not provide the necessary level of protection. Such tests as required by the Fire Commissioner shall be conducted at the owner's risk by his or her representative before a representative of the NYC Fire Department every 2 years. Maintenance. At least once a month, an inspection shall be conducted by AS-15 Certificate of Fitness holder to assess whether the system is in good working order. Foam fire extinguishing systems shall be maintained in good working order at all times. Any foam fire extinguishing system that is not in good working order shall be repaired or replaced as necessary to restore such system to good working order, or, where authorized by the building code, removed from the premises. Only AS-15 Certificate of Fitness holder employed by Class A licensed Master Fire Suppression Piping Contractor, MFSPC, properly trained and having the knowledge of the installation, operation and maintenance of the specific foam fire extinguishing system, shall inspect, test, service and otherwise maintain such system in accordance with the NYC Fire Code and NFPA 25, 2011. Foam water sprinkler system types. Foam water sprinkler systems are similar to fire sprinkler systems in their operation. Pre-primed foam water systems. Operation is the same as a wet sprinkler system with fusible links on the sprinkler heads or discharge nozzles with system piping charged with a foam solution. Dry pipe foam water systems. Operation is the same as a dry pipe sprinkler system using sprinkler heads or discharge nozzles with fusible links and system piping under pneumatic pressure. Upon the operation of a fusible link, the pneumatic pressure is released and the dry pipe valve opens, permitting the water/foam solution into the system. Pre-action foam water sprinkler systems, equipped with sprinklers or nozzles with fusible links along with a detection system in the protected area that may be electrically, hydraulically, or pneumatically operated. A manual release is also required for tripping the control valve. System discharge piping may or may not be pneumatically supervised for piping integrity. Deluge foam water sprinkler systems, equipped with open nozzles and are operated by a detection system in the protected area that may be electrically, hydraulically, or pneumatically operated. A manual release is also required for tripping the deluge valve. Foam concentrate solutions are specifically manufactured to suppress different types of fires and are grouped as follows. Class A foams operate by lowering the surface tension of water, assisting in the wetting and saturation of Class A fuels, which include wood and paper. These foam solutions are unable to control the explosive vapors produced by flammable liquids and are not appropriate to protect Class B fires. Class B foams operate by smothering the fire by removing oxygen from the fire triangle. They also form a film over the flammable liquid to contain the flammable vapors. These foams are the most common type used in foam water sprinkler systems. Class B foams are classified as synthetic or protein. Protein foams from non-animal sources are preferred due to their limited biological components that are less harmful to the environment. Alcohol-resistant foam concentrate, used for fires on water-soluble materials and hydrocarbon fires and other fuels destructive to AFFF or FFFP foams. These foams will form a blanket over the surface of the alcohol. Aqueous film forming concentrate, AFFF, a concentrate based on fluorinated surfactants with a foam stabilizer and are diluted with water to a 1%, 3%, or 6% solution. These foams have the ability of spreading over the surface of hydrocarbon-based liquids. Film-forming fluoroprotion foam concentrate, FFFP, a concentrate that uses fluorinated surfactants and produce a fluid aqueous film and is used to suppress hydrocarbon fuel vapors. Fluoroprotion foam concentrate, similar to protein foam concentrate with a synthetic fluorinated surfactant additive. Medium and high expansion foam concentrate, used in specially designed equipment and have a foam-to-solution ratio from 20 to 1 up to 1000 to 1. Foam room. Foam room is designed to store equipment used for creating and supplying the foam to the designated areas. In this room the foam concentrate and the water are automatically mixed and distributed through piping system and to the foam heads. Where a fire department connection is provided, it must be installed as part of the foam fire extinguishing system. The fire department connection may be designed to either supply the water to the foam room or finished foam solution to the storage tank area. It is critical that the foam room has all the labels properly posted, as per diagram. For example, every valve shall be labeled in the foam room so that in case of an emergency, time is not wasted in determining which foam valve controls the flow to the specific storage tank area. Foam water sprinkler and spray system components. Discharge devices for foam water wet pipe, dry pipe, and pre-action systems are required to be automatically operated and must be non-air aspirating. Standard spray sprinklers are commonly used in these systems. Discharge devices for deluge systems are permitted to use air aspirating nozzles and also standard spray sprinklers. There must be a reserve supply of foam concentrate available to place systems that have discharged back into operation within 24 hours. Foam water discharge devices, such as chambers, and foam outlets shall be inspected visually and maintained to ensure that they are in place, and are free from external loading and corrosion. Where caps or plugs are required, the inspection shall confirm they are in place and free to operate as intended. Foam concentrate proportioning, positive pressure or balanced pressure injection are the preferred methods of supplying foam concentrates into the water flowing through the supply piping. Piping schematics illustrating all components and configurations may be found in NFPA 11 2005 edition and are broken down as follows. 1. Balanced pressure proportioning systems use a foam concentrate pump that discharges through a metering orifice that has the foam and water pressure maintained using a pressure balancing valve. 2. Balanced pressure proportioning system utilizing a pressure proportioning tank with a diaphragm or bladder that separates the foam from the water. This arrangement discharges the foam concentrate through a metering orifice into a proportioning controller. 3. Inline balanced pressure proportioning system using a foam concentrate pump or bladder tank. A pressure regulating valve is placed in the pump return line and maintains constant pressure at all design flow rates. It is required that the constant pressure be greater than the maximum water pressure. 4. Foam concentrate pump discharging through a metering orifice into the piping system riser with foam pressure at the upstream side of the orifice greater than the water pressure in the system riser greater by a specified design value. Other positive pressure injection systems that are listed may be also used, including inline inductors, around the pump proportioning, and balanced pressure injection systems utilizing a foam concentrate pump with a variable speed motor that matches pump output to water flow rates so as to maintain the correct percentage of required foam concentrate. Foam concentrate pumps. These devices shall be maintained and tested using the same frequencies of fire pumps and shall be equipped with pressure relief valves and connections to facilitate draining and flushing. These pumps shall start automatically when the system activates. Foam concentrate tanks. These tanks must be located in areas not subject to temperatures below the foam manufacturer's requirements and must be permanently mounted. Atmospheric type storage tanks. These tanks must be fitted with manholes located to allow for inspection of interior tank surfaces, connections for pump suction, relief, testing lines, liquid level indicators along with filling and drainage connections. Foam delivery system types. Methods of delivering foam concentrate to the system include: standard proportioner, are devices that are specifically and uniquely designed for each particular system. The way the proportioners work is by introducing the concentrate into the flow of water. Works without any extra pressure on the foam concentrate. Bladder tank proportioner, is similar to a standard pressure proportioner, except the foam concentrate is contained inside a diaphragm bag that is within a pressure vessel, uses extra pressure. Operation is the same as a standard pressure proportioneer, except this system can be used with all foam concentrates, regardless of specific gravity. Most common foam extinguishing systems shall be color-coded as follows. Piping, valve bodies and handles, red with contrasting bright orange bands. Fire department water connections, red. A durable sign that reads, "Water for foam system," shall be conspicuously posted immediately adjacent to such connections. Fire department foam connection, red with contrasting bright orange band or caps. A durable sign that reads, "Chemical foam direct TO tanks" or 3% mechanical foam solution direct TO tanks, shall be conspicuously posted immediately adjacent to such connections. Former S12 and new S12, list of major changes. The following information is taken out of the new S12/S15 Certificate of Fitness study material. Below is a list of major changes. Responsibilities of a fire watch personnel when a fire protection system is out of service, FC 901.7.2.1, planned removal from service, impairment coordinator responsibilities, fire watch, 901.7.3, records, all system inspections, tests, servicing and other maintenance shall be maintained on the premises or other approved location for a minimum of 3 years, FC 901.6.2. In addition to those records required by NFPA 25 as mentioned above, an approved card bearing the dates of each inspection, certificate of fitness number and signature of the certificate of fitness holder shall be posted on the premises near the main water supply control valve. This approved card shall not replace or supersede the detailed record of inspection, 901.6.2.1. Definitions, 3.3.4.1 NFPA. Critical deficiency, a deficiency that, if not corrected, can have an effect on the performance of the fire protection system. Non-critical deficiency, a deficiency that does not have an effect on the performance of the fire protection system, but correction is needed for the proper inspection, testing, and maintenance of the systems. Fire pump, automatic standpipe, a fire pump located at or below street level that supplies the lower 300 feet, 91.4 m, of a standpipe system or a combined standpipe and sprinkler system. Fire pump, foam, a fire pump used to boost water supply pressures in a fire protection system where such system uses firefighting foam as an additive. Fire pump, limited service, a fire pump with a motor rating not exceeding 30 horsepower and utilizing a limited service fire pump controller. Fire pump, special service, a fire pump that is located above street level and that receives its water supply from a gravity tank or suction tank. Fire pump, sprinkler booster pump, a fire pump that supplies sprinkler systems only. Fire pump, water mist system, a fire pump used to boost water supply pressures in a fire protection system where such system utilizes water misting technology. Automatic pressure maintenance device, maintains pneumatic pressure on the piping system set to specific limits by controlling a plant air system, a single air compressor, or a nitrogen supply. System types, automatic wet sprinkler system, antifreeze sprinkler system. The freezing point of solutions in antifreeze shall be tested annually by measuring the specific gravity with a hydrometer or refractometer and adjusting the solutions if necessary. Annual testing must be performed in accordance with NFPA 25/2011. Control valves, System Control Valve Signage, FC 903.5.4. A sign identifying the location of the sidewalk box housing the sprinkler system control valve shall be conspicuously posted on the exterior wall of the building directly opposite the sidewalk box. Such sign shall have red letters 1 inch in height on a white background and red, "Sprinkler System Shutoff Valve," indicate distance, feet opposite this sign, or other approved design. This was in 1968 building code but was omitted in the 2008 codes. Fire Department Connections, FC 312.3.2. Fire Department connections must always be accessible. A working space of not less than 36 inches in width, 36 inches in depth and 78 inches in height shall be provided and maintained in front of and around wall-mounted and freestanding fire department connections, except as otherwise required or approved. Sprinkler System Control Valve Signage, FC 903.5.4. A sign identifying the location of the sidewalk box housing the sprinkler system control valve shall be conspicuously posted on the exterior wall of the building directly opposite the sidewalk box. Such sign shall have red letters 1 inch in height on a white background and red, "Sprinkler System Shutoff Valve," indicate distance, feet opposite this sign, or other approved design. Special service pumps. Special service pumps are sometimes used in sprinkler and standpipe systems. These pumps are small pumps with limited power taking suction from gravity tanks. These pumps are used when the water pressure available does not quite meet the needs of the sprinkler/standpipe system. This small pump increases the water pressure and volume in the sprinkler/standpipe system until it reaches acceptable levels. The special service pump should not be confused with the pressure maintenance pumps, jockey pumps. Special service pumps shall be maintained according to NFPA 25 standard for fire pumps.